3.4. All right, so here we're talking about composition. We're going to get into composition of functions. Composing functions together. So, like, you know what a musical composition is, when the different instruments get together and together make a beautiful piece of music, right? All the instruments together. Well, that's what we're going to do with these functions. We're going to compose them together. So how exactly are we going to compose them together? Well, they're telling us right here, F, that weird little circle thing, F circle G, like that. What that means, whenever they do that, that means take G and plug it into F. Take G and plug it into F. So I'm going to take all of G and I'm going to plug it in right there to F, to the X spot. Because remember, in a function, the X is the insert slot, isn't it? It's like the holes in the top of a toaster. It's where you plug stuff in. So I'm going to plug all of G into F. So what will become of that? That'll be 4, and then comes G, 4x squared plus 4x plus 5. Everybody getting, I'm going to need to distribute and gather any like terms, but is everybody good so far? See how I just plugged all of G into the X slot for F there? And then we distribute. Like that, we get 16x squared plus 16x plus 5. There we go. Is that okay? Questions I can answer on that one? 2. I'll do it over here where we can see it. So number 2 says f of x is 1 over x minus 4. And g of x is 4 over x plus 4. Okay. And then they're asking us on the first part, they want f of g of x. Well, do you see how that has g inside of f? So that means I need to take all of g and plug it in right there into f. Everybody see that? So that'll become like that. Does everybody see how this right here is the G? Like that? Is that making sense? So now I need to work that out. Well, actually, first off, I can just cancel those 4s, huh? Plus 4 minus 4. Is that good so far? Plus 4 minus 4 is 0, so they're just gone. How we doing? Are we good to hear? We had this a few minutes ago. Right? We get fractions over fractions. Remember what you do. You take aim at the denominators. Now, all the ones under little bars, remember? Who's the only thing under a little bar? X. He's the only one under a little bar. There's no other way to say that. All right. So what do you do with that? You multiply top and bottom by that. Right? X here. X. And it's X over 1. Right? X alone is X over 1. Right? And what happens? Well, these cancel, don't they? So on the bottom, we just get 4. On the top, what's 1 times x? Just x. Done. Fractions over fractions. Just multiply top and bottom by all the items under a little bar. There's only one item under a little bar, that little x. So I multiply top and bottom by x, which is the same as x over 1. So it cross cancels. See how that gets rid of the extra fraction stuff? Just makes it a normal fraction. On the top, it's just 1 times x, so it's just x. On the bottom, the x's cancel. It's just 4 over 1. I don't need the 1. 4 divided by 1 is just 4. So there we go. There's that answer. Now, on part 2, they want us to go the other way. Questions on that one? All right, let's go the other way. Now on part 2, they want us to go the other way. This time, we're going to put all of f into g. So it's the other way around, isn't it? So I'm going to take all of f here, all of f, and plug it into g there. All of f in for g. So what do we get? We get 4 over, and then you're going to put all of f down there, which is 1 over x minus 4 plus 4. See how this right here is f, having been plugged into g? Is that good to there? Now, look at that first ugly thing. It's fractions over fractions again, right? This first part, this is fractions over fractions. So what do we do with this guy, which is just him? Forget about the plus 4. We'll come back to him later. But what do we do with fractions over fractions? Every time we find anything under a little bar and multiply top and bottom by whatever's under the little bar, right? What's under the little bar? X minus 4. X minus 4 over 1. So these cancel, huh? Is that good? See how we always do that? Whenever you have fractions over fractions, multiply top and bottom by everything under the little bar. Okay, so what does that give us? Well, on the top, it's going to be 4x. In fact, maybe I better come over here to the side. We have a couple more steps to go. So 4x minus 4 over 1 plus 4. See how there's just a 1 on the bottom now? We can just skip it, really, huh? Because we don't care about 1s on the bottom. Everybody see what happened? See how nicely that works? Whenever you have fractions over fractions, multiply top and bottom by whatever's under the little bar. And then distribute. 4x minus 16 plus 4. 4x minus 12. So yeah, let me go back. It'd be good just to do a little instant replay there of what just happened. All the mess was over here, huh? So yeah, so what I'm doing is I'm basically putting f into g. F into g. So I'm going to take all of f here, and I'm going to plug it in right there in g. So let me write out the g function. It's 4 over x plus 4. That is this g function. But in this spot right here, I'm supposed to plug in all of f. What is f? This. 1 over x minus 4. So see how that's all of f plugged in to this x spot? And now, once we get to there, we go, oh, okay, now that's a fraction over a fraction. What do we always do with a fraction over a fraction? You look at what's under the little bar, and you multiply top and bottom by whatever's under the little bar. In this case, x minus 4. And this is over 1. Anything alone is over 1, really. Cancels. And so that explains how we get this. And it becomes 4x minus 12. 3, they're going to give us f of x equals x over x minus 3. And g of x equals 6 over x. All right. And then they're asking for f of g. Okay. Can you do that one? So that means all of g plugged into f. Let me give you a second. Remember this, so we're going to take all of g. See how g is inside of f? We're going to take all of g and we're going to plug it in right here and right there. Remember, those are the holes in the toaster. You got to plug into both of them. That's what the x is in a function. It's the insert slots, the holes in the toaster. So you got to plug it into both of those. And so then what you get is 6 over x, over 6 over x minus 3. Does that make sense? The first step, to plug in. And now you know what to do with fractions over fractions, right? You look at everything under little bars, and there's only one thing under those two little bars, x. You don't need both. You don't need x squared. Just use one of them. You just need one, and multiply top and bottom by whatever's under the little bar, which in this case is x. Now remember, when you do it, it's going to be x over 1, and here also, even the 3, you got to do all the terms top and bottom, because you got to have equal treatment. Equal treatment, top and bottom. We good? This making sense? So these x's cancel, these x's cancel. What do we get? 6 over 6 minus 3x. Exactly. Good. Yeah, so everybody see Faith's right on the money. We can't cancel those 6's, can we? Because of the glue on the bottom, the Costco glue, right? With pluses and minuses. So that bottom is saying, no, don't you cancel me unless you buy us both. In other words, we go like that, or we do nothing on the bottom. They're a package deal. You buy them all, the 6 and the minus 3x, or you buy nothing. You can't say, I just want the 6, thanks. I don't want the minus 3x. Can't do that, right? Plus and minuses glue things together, make them a package deal. So we can't do that. We cannot cancel the 6's. But how do we get around the Costco glue problem? We factor, remember? How do you factor that bottom? What do they have in common on the bottom? 3. 3 goes into both of them, huh? Take out a 3. And then what would it multiply by to go back? 3 times what will go back to 6? 2. And 3 times what will go back to minus 3x? Negative x. Yeah. And the top still has a 6 up there. Good so far? See how we just factored that bottom, took out a 3? You could redistribute it. It'd go right back to 6 minus 3x, wouldn't it? And now, well, okay, yeah, so what though? Why did we do that? Well, do you see what we can cancel now? Can I cancel that 3 into that 6 2 times? Is that okay? Yeah, there's no, he's not glued. So that's okay. See, that 3 does not have a plus or minus next to him. So yes, you can do it. See how factoring gets around the glue problem? Because it makes it multiply. So it's no longer added, subtracted. So you get around the problem. Do you see that? So that's what we do, and that's right and good. So what's the final answer? 2 over 2 minus x. And we cannot cancel those 2's. We're just done. We don't need the parentheses on the 2 minus x on the bottom anymore because there's nothing to separate it from. Before it was separated from the 3, but that's gone now. And they ask you to go the other way, don't they? They say, okay, that's all good. Now do g of f. You need to do g of f. Plug f into g. Take all of f and stick it into g. Into the x slot, the input slot for g. Okay, so we take all of f and we plug it into the holes, the x slot in g, right? So it's going to become 6 over, and then I'm going to plug in all of f, which is x over x minus 3. Is everybody good so far? See how we put all of f inside of g. Just like it said here, put all of f inside of g. So I plugged all of f into the x slot of g. Okay, now, fractions over fractions, yet again. You guys get to be pros at this now, right? Fractions over fractions. What do you always do? You find what's under the little bars, and you multiply top and bottom, all the terms by that. Huh? So what's under the little bar? X minus 3. So multiply x minus 3 top, x minus 3. And it's really x minus 3 over 1, so it cancels. That's why we do it, because it cleans things up by canceling them out. And so what are we left with? On the top, 6, x minus 3. On the bottom, what's left on the bottom? Just x. X over 1, but we don't need anything over 1. We don't show the 1, do we? Just x. You can leave it that way or you can make it 6x minus 18. It's good. Both are good answers. Both are good and right. It doesn't really matter. And you can't simplify any more than that. Good, let's go for number 4. I want you to see what they have. So number 4, there it is in the middle. The function h of x equals x plus 7 to the 5th can be expressed in the form f of g, where f is x to the 5th and g is defined below. So basically they're having us do the composition, the composing of two functions together backwards. In other words, they're giving us the final answer. They're saying what we want is x plus 7 to the 5th power. And they're saying, how do we get that? How do we get x plus 7 to the 5th power? Well, they're saying you could take x to the 5th, you could take f of x is x to the 5th, and then you could take g and it be something what that you plug in right there and it becomes this. That's our goal. This is what we want. It's our goal. So what would g need to be to plug into f and make it the thing that's our goal? What would it need to be, Lajane? Yeah, right. Does everybody see that? That g would just need to be the x plus 7. Then when you plug x plus 7 in right there, you'll get that, won't you? So that's all they want. They want you just to kind of think it backwards. Just want to say, hey, what would it be to make it work? So that's it. That's all we got to do on that one. It was like a work backwards one. Questions on that one? Want to try number 5? It's the same kind of thing. They're asking you to think about it backwards. They're saying the function can be expressed. So again, that's our goal. That's what we want. We want 1 over x plus 6. And how do we do it? Well, f of g, you want f, and you want to put g inside of f. And they're saying g, this time they're giving you the inside. They're saying the g is the x plus 6. That's the g. That's what you're going to plug inside. What is the f? What is the f function equal? What is the outer structure that you're going to plug g into to produce your goal of 1 over x plus 6? 1 over x, exactly. Did y'all see that? It's got to be 1 over x, doesn't it? Because if you take that and plug it in to the slot, you'll get your goal, won't you? So the f has to be 1 over x. They just want us to think those backwards. They want us to see from every angle how two functions compose together. Now they're going to give us kind of like a little bit of a word problem where they have us think about functions and how they compose together. So the function d of p gives the number of items that will be demanded when the price is little p. The production cost is the cost of producing x items. To determine the cost of production when the price is $6, you would, and then they're giving us all those multiple choice options. So this goes to do you really get what we're doing? How well do you really understand what we're doing? So let's go back and read it careful. D of P is the number of items that will be demanded. That's what the D stands for, demand. Demanded when the price is P. You know, supply and demand economics, right? When prices go lower, people demand more. They want more. When prices go higher, people demand less because there's less people willing to pay the higher price. So demand as a function of price. That's what an economist would say. Demand is a function of price. So, okay, and then they're saying, and the production cost is the cost of producing X items. So this is demand. D is demand at price P. And C of X is the cost of producing X items. Cost of producing X items. And then here comes their question. So to determine the cost of production when the price is $6, how are we going to do that? When the price is $6. So the price is going to need to go right there, isn't it? Because P is right there. So that's going to be D parentheses 6, isn't it? Right? It's going to be the demand when the price is 6. Demand, like how many the public is demanding? We would like to buy 10,000 of those whatevers at that price. So that's D of 6. Now, but they asked cost. So then you're going to have to plug that, because that's in there, to the cost function. Because X is, they're going to have to produce what the people are demanding. The people are demanding 10,000 of those whatevers. Then the factories will produce 10,000. And the cost will be C of D of 6. It's right here. C of D of 6. Does that make sense? So the $6 is the price. That has to go in for P. So we know it's got to be D of 6, doesn't it? Even just that, there's only one option with D of 6. How about just that? Even if you don't understand everything else, you know it's got to be D parentheses 6, because this is P price and the price is 6. So it's got to be D parentheses 6. Now, why does that plug in for X here? Well, because the amount that people demand is the amount they will produce. The factory's going to produce what people are willing to buy, what they demand. So that becomes X and plugs into C. All right, let's try number 7 here. Given the following functions, find each of the values. So now this one's pretty simple. I think this will be easy for you. This one is to add 2 functions, subtract 2 functions, multiply 2 functions, and divide 2 functions, and plug in. So basically, we're just going to plug in whatever they're telling us to both F and G, and then just add the answers, subtract the answers, multiply the answers, divide the answers. It's really no big deal. So for this first one, for example, we're plugging in -2. So let's find F of -2, and let's find G of -2. So if you plug -2 into the F function, that'll be -2 squared minus 5 times -2 minus 6. If you use your calculator, I think it comes out 8. Yeah, and then G of -2, going to plug in right there, -2 minus 6 minus 8. See that there? You guys able to get that in your calculators okay? Coming out positive 8 for the first one. So right, I just took -2 and I just plugged in there and plugged in there into F, and then I took -2 in the second part and plugged in there for G. Right? So the X in a function, again, is the holes in the toaster. It's the insert slot. Plug in here. So I just put in -2 for the X spots in F and -2 for the X spot in G. Worked them out. Now, last thing, we're supposed to do what with those numbers? Add them. So -8 and 8, add them up. What is that? -8 plus 8, 0. Or it's the other way, huh? Whatever, it's still 0. It's 8 plus -8, it's 0. Questions on that? Is that making sense? The second part, we're supposed to now, part 2, we're supposed to plug 5 in. So I'm going to say, okay, what's F of 5? 5 squared minus 5 times 5 minus 6. Use your calculator. I think it's just minus 6. And then G of 5 is -1. So far, so good. I'm just plugging 5 now in for F and in for G into the X slots and working it out. And then I'm supposed to take those two numbers, minus 6 and minus 1, and do what between them in the second part? Subtract. So in the first part I added, in the second part I'm subtracting the two answers. And so we're getting the double negative thing, aren't we? So what's that double negative going to do? Going to go to positive, yeah. So that'll be, what is that, minus 6 plus 1 would be minus 5 for that answer. With the multiplication, so now I'm going to plug in negative 5 to F. So that'll be, I'm running out of room here, to F. So that'll be negative 5 squared minus 5 times negative 5 minus 6, 44. And then negative 5 into the other function, into G. So that was F of negative 5, and then G of negative 5 is going to be negative 5 minus 6, negative 11. And then what am I supposed to do with those two numbers? Times them, yeah. 44 times minus 11. 484? 484. Thank you, Dalton. I mean, I could have done it in my head, but I hate to show off, so I just took Dalton's answer there. Yeah, no, thank you. Okay, the last one, we're just going to plug in negative 1 to F. Oops. Use your calculator. So it's going to be 1, 6, 0. I think it's 0. And then G of negative 1. Is negative 1 minus 6 is negative 7. Good to there. And then what are we supposed to do with those two numbers? Divide them. So 0 over negative 7. What is 0 divided by anything? Just 0, huh? There's our answer, 0. So there we go. There's all four parts. Let's just plug it into the two functions and add in the answers or subtracting or multiplying or dividing. Number 8. All right, so now they're saying take those two functions and add them, right? See how they have F plus G here? So that's pretty easy. This time there's no numbers to plug in. See how it's just F plus G of X? There's not a number to plug in. They're not saying, it's not like, look back at the last one. See how this was F plus G of negative 2. So we plugged in negative 2 to both of them. This one's just F plus G with X. So you just take the function F of X, and then you add the function G of X. And see what you get. So add those up, what do you get? 2x squared, I'm just going to gather like terms. 2x and 5x, 7x plus 2, done. How about number 9? What are they saying down here on number 9? What's up with that? There's no symbol between F and G. What does that mean when you put two letters right next to each other with no symbol in between? What's their relationship? Multiply, huh? That means F times G. So I just take, so this is multiply. So I just take the F function, 5x plus 4, and I multiply the G function, 2x squared plus 2x. There we go. So let's do it. Boom and a boom. So we get, so remember how to multiply letter things? You multiply the numbers in front, add the powers. Multiply the numbers in front, add the powers. So 5x times 2x squared, 10x cubed. And plus 5x times 2x, 10x squared, because they have invisible 1 powers when they have no power showing, right? Out front numbers multiply, powers add. The 5x is done. He went to both of the other two. And now the 4 is going to go to both. That'll be 4 times 2, 8x squared, and 4 times 2, 8x. So they never told me to plug in for x, did they? See how it was just fg of x instead of a number? So I never plugged in. Last thing, I've got to gather like terms, huh? These two in the middle. So 10x cubed, 18x squared, 8x. There we go. And here. So now they're giving us a function f and a function g, and they're dividing them, right? So let's do that. X squared plus 4x plus 3. That's f. On the bottom, g. Like that. That good so far? Now, so here's a time, like we are going to want to factor. Why? Because I want to cancel things. I can't cancel right now because they're all glued together, right? I can't cancel these 3's. I can't cancel anything because it's all plussed together. It's all glued together, the Costco glue thing. So what I do is I factor. So now's the time you factor when you want to reduce things. So now I want to reduce, so I'm going to factor. How do you factor the top? X is in the front. What multiplies to be 3 and adds to be 4? 3 and 1, huh? Both positive. They'll multiply to be 3, add to be 4. And then the bottom stays the same. And now, you see what we can do? Now we can cancel. So that's the purpose of factoring, to get that to happen so you can cancel. So what is the answer? It's just x plus 1. It just becomes x plus 1 on that one. Now, they asked me a follow-up question, which might seem kind of strange all of a sudden out of the blue. They say, what's the domain of f divided by g? What's the domain? Didn't we talk about domain last time? Or recently? I'm losing track a little bit. But I think recently we did domain. Remember, domain asks for the 2 trouble areas, right? It says things that would cause a problem. Remember what the bottom of a fraction can't become? Can't become 0. You can't divide by 0. Remember, you can never let the bottom of what? What is like 17 over 0? It's not 0. 0 on the top would make it 0. This is infinity. Your calculator will tell you error usually. If you divide by 0, it's infinity. Right? Because think about what a fraction is. If I go 10 divided by 2, what's the answer? 5, because 2 goes into 10 5 times, right? Bottom goes into top. That's what a fraction means, right? Bottom into top. So how many times does 0 go into 17? By that same thought. Forever. Huh? It's infinity. It's not 0. If you have 0 on the top, that's 0, right? If I said last night I had 0/17 of the pie. Pie was cut into 17 pieces, and I had 0. That's just a weird way to say 0, right? No pie. I had no pie, right? So 0 in the top is fine. But 0 in the bottom, that's not fine. That's the problem area. That's infinity. It's not even a number. So we can never let the bottom of a fraction be 0. So whenever they say domain, they're saying what's allowed. What x's are allowed. And we think, oh, well, you can't allow any x that'll make the bottom 0. Well, look back here to this last question. See what was down here? X plus 3. So x plus 3 cannot equal 0. The bottom cannot. That's a not equals, notice. Normally we do equals, huh? That's a not equals. And then how do you solve that for x? Just subtract 3. So x cannot equal negative 3. There's the answer. You see how you cannot, why not? If x was negative 3, if you put in negative 3, see how it would make that bottom 0, negative 3 plus 3? It would make that denominator 0, wouldn't it? And that makes the whole thing infinity. On that. Yeah?
Isn't it supposed to be x plus 1?
Yeah, good question. Even though it's simplified down to this, if even for a moment, that's exactly their point. I'm glad you're tracking with that. That's exactly their point. If even for a moment prior to simplification, there was something in the denominator, we still have to restrict it. We still can't let it be negative 3 because that would have made it before simplification 0 at the bottom. Yeah, good question. Yeah, because in the end it just cleaned up to be x plus 1, but it had something in the bottom in the beginning. So we still have to look at that. Yeah, good. That's their point. Glad you caught it. The next one, all right. So 11. So they're giving me f of x as that. They want f of x plus h and f of x plus h minus f of x. Okay, let's do it. So number 11. So f of x equals x squared plus 5x. Or is it minus? It's minus, isn't it? Minus 5x plus 5. Okay, and then they want, for the first part, f of x plus h. Okay, yeah, so they want you to simply take x plus h and plug it in to the f function. I think you're getting better and better at plugging in functions. Take this, and it's going to plug in right there and right there, isn't it? The whole x plus h. That whole x plus h will plug in those two spots. So plugging that in, I think you guys are on track. We're going to get x plus h squared minus 5x plus h plus 5. Okay, and so remember what we do when there's a 2 power on something? That means to write 2 of those parentheses and do first to both, second to both. So I got to go x plus h, like that. And then this minus 5 will distribute. Minus 5x minus 5h plus 5, okay? And so now I'm going to go x to both, be x squared plus xh, and h to both, plus xh plus h squared. And then just bring everything else down, minus 5x minus 5h plus 5. Are we good to there so far? See how we did that? Just whenever there's a 2 on a parentheses, right, write 2 of them, first to both, second to both. Okay? And now, gather like terms. These 2 are like terms. They're really the only ones, huh? So that'll just be x squared plus 2xh plus h, right? Because it's 1xh and 1xh makes 2xh. Well, canceling would be if there was 1 positive and 1 negative. Right? Then they would cancel. But if they're both positive, they just adds plus 1 and plus 1 makes plus 2. And then everything else there, minus 5x minus 5h plus 5. So there's the answer to the first part. And then in the second part, they ask us, what do they want in the second part? They want us to do a little bit more. So I'll draw a line here. They want us to do f of x plus h, which is everything we just did, minus f of x. Does that make sense? So they want us now to take that whole answer we just got, right? Because that was f of x plus h, wasn't it? F of x plus h is that whole thing in the box there. So they want us to do that first. Let's do it. So that'll be x squared plus 2xh plus h squared minus 5x minus 5h plus 5 minus, and then, right, all of this is the first one, and then minus f of x, and f of x is the original function, isn't it? It's x squared minus 5x plus 5. That is the f of x. that good? You don't really need parentheses on the first part. It's okay if you want to put them. But you definitely need parentheses on the back part because that minus is going to distribute through and change all those signs, isn't it? So let's do that. So now the minus is going to go boom, 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 and we'll get minus x squared plus 5x minus 5, like that. And I bring down the first stuff. X squared plus 2xh plus h squared minus 5x minus 5h plus 5. And then we're going to cancel. And so x squared minus x squared minus 5x plus 5x, 5 minus 5. See how all that stuff cancels? Remember we did these with the difference quotient earlier, right? Where we had the fraction and the h on the bottom. Remember all the non-h terms drop out? See how all the terms that don't have an h in them cancel? That's what always happens. What are we left with? 2xh, only h stuff, plus h squared minus 5h. That's it. There's our answer. It's just a little review of that fraction kind of stuff. All right, so number 12. So this is a good question. You know, when your math teacher says that, you know it's going to be on the exam next Tuesday, right? I just think this is a valuable question. It really makes you think about graphs and composition and plugging into one thing and the other. So there's one. You'll see it on the practice. It won't be a surprise. We do the practice exam on Thursday. There'll be one just like that. And anything on the practice exam, you know, is going to be on the real exam. So no surprises. Let's take a look at this with our last few minutes here. So, okay, this is weird at first. Then once you get the hang of it, you'll snap it out. So, g of 3. So you start on the inside. Remember, we're going to put 3 into the G machine. It's like the toaster, you know. Plug in the bread, it pops up toast. And then when it pops up, then we're going to plug into the F machine. It goes from the inside out. That's how functions always work, huh? Like if I go f of 2, we know 2 goes into f. It's always right to left, isn't it? Like that. So no big surprise here. All right, so how do we do that? Well, 3 into the, now remember what's on the very inside is always x. So an x value of 3 plugging into g. So the g graph is the one on the right. Find x value of 3, go up to the graph. There. Right, that's the position 3, 4, isn't it? So when you put in an x value of 3, you get a y value of 4 coming out. Remember what I said about y values are function values? So that's the same as a g value. A y value is a g value or f value. You know, they're function values. So we're on the g graph, it's a g value. So that means if you plug in 3 to the g function, you're going to get out 4. So what pops out here is 4, and then you put that into f. Are you tracking with me? So we put 3 into G, went to the graph, found the point, out come 4, and now that 4 is going into F. Do you see it? Because, again, back here, whatever you plug into G, I plugged in 3, out came 4, and now that has to go into F. Why? Why into F? Because all of G is inside of F. See that? So whatever, see how they're putting all of G inside of F here? So whatever comes out of G is really going into F, isn't it? Because all of G is in F. So, so now you're putting 4 into F, right? All of G is in F. Now you're putting 4 into F. So go right here on the F graph. That's the point 4, 0. Put in 4, you get out 0 is the answer to that first one. So you got to run it through both functions. You see how I did that? Try that next part. G of f of 1. Start with a 1 and work your way back out. All right, I was going to do something slower, but we better move. All right, let's try it. Let me show it to you. So we got to put 1 into f. So this time we're starting with the f graph. Putting in 1, boom, 1, 3. So when you put an x value of 1, you get out an f, or y, same thing, value of 3. So f becomes 3, but f, notice, is inside of g. So that means you're putting 3 into g. So what happens then? You put 3 into g. Boom. 3, 4. Out comes, right, put in x is 3. Out comes g or y. Same thing, 4. Answer is 4. How we doing? Questions I can answer on that one? Let's try one more. How about f of 2? Can you do that one? Okay, so now f of 2 puts 2 into f. So go to the f graph, put 2, go to the graph, 5. Put in 2, get out 5. Put in x is 2, get out an f value of 5, right? So out comes 5, but then that 5 is put back into f because the f's in the f. So what comes out of the inside f goes into the outside f. So now put in 5 to the same function. Boom. Over 5 up 2 comes back to 2. Look at that. I'll do the last one. What about g of 5? 5 into g. Here's 5. Right there. 5, 2, put in an x, get out a g value 2. And then that 2 goes into g, put in 2. Get out 1. X value, g value 1.